Today we are going to discuss about angle modulation. If you take angle modulation, there are two types. One is frequency modulation called as FM and second is phase modulation called as PM. If you take your carrier voltage, any carrier voltage mathematically can be represented as Vc of t is equal to Vc into cos of omega ct plus theta c of t, where Vc is the carrier voltage, omega c is the carrier frequency and theta c is the initial phase angle of the carrier. Together, omega c and theta c is called as total phase angle of the carrier. Suppose frequency modulation here refers omega c, that is frequency of the carrier is changed in accordance with the modulating signal voltage. It is known as frequency modulation. Similarly, theta c, which is nothing but phase angle of the carrier. So this phase angle of the carrier is varied in accordance with the modulating signal voltage. It is known as phase modulation. So Vc refers carrier voltage, omega c refers carrier frequency, theta c refers initial phase angle of the carrier. Then D-type we are going to discuss about phase modulation. Suppose if you take phase modulation, as I have told you already, it is nothing but phase angle of the carrier is varied with respect to the modulating signal voltage. So the changed phase angle of the carrier is represented as theta I of t. So this theta I of t is actually proportional to Vm of t. As you know, Vm of t substituted in theta I of t. So theta becomes Kp into Vm of t. So theta I of t is nothing but Kp into, after substituting Vm of t, it becomes Vm cos omega mt, where Kp is the phase sensitivity constant. With the theta I of t, if you replace the phase angle in carrier voltage, then Vc of t becomes Vpm of t. So Vpm of t is nothing but Vc, where Vc is not been changed, and cos of frequency also not been changed for phase modulation, and theta alone is being changed for phase modulation. So that changed phase angle of the carrier is represented as theta I of t, as we have discussed already. So theta I of t is being replaced by Kp into Vm cos omega mt. So if you take this Vpm of t signal, in Vpm of t you have got a constant called Kp into Vm. It is referred as, together it is Mp. So where Mp is called as modulation index of PM. So finally, Vpm of t equation is going to be Vc, that is carrier voltage is maintained constant, carrier frequency is maintained constant, only phase angle of the carrier is being varied. After the variation, the constant is being referred as Mp, which is called as modulation index of PM. So this is the mathematical equation of your phase modulated signal. Since phase modulation signal is analogous to frequency modulated signal, similar to phase modulation, frequency modulated signal also can be written as Vfm of t is equal to Vc as usual, cos of and carrier signal frequency omega ct plus, instead of Mp you have to replace by Mf for frequency modulation, where Mf is nothing but modulation index of frequency modulation Fm. So it is Mf into cos omega mt. So if this is your Vpm of t mathematical expression for phase modulation, and Vm of t is the final mathematical expression for frequency modulated signal. Waveforms next we are going to see. Here I have just drawn 5 waveforms. First one is going to be modulating signal voltage. Second one is AM signal. Third is carrier signal waveform. Fourth is FM wave. Fifth is PM wave. So if you just see the modulating signal voltage, it is of low frequency and carrier signal is of high frequency. And if you see AM signal is nothing but amplitude of this carrier is being varied as per your modulating signal voltage. So this is your AM signal. See FM signal. In FM signal we are going to vary only the frequency of the carrier, not amplitude of the carrier. So how it is being varied now? We have to vary the frequency of the carrier as per your modulating signal voltage. So when modulating signal voltage amplitude increases, and we are going to increase the frequency of the carrier also. So when modulating signal voltage is less, the carrier frequency is maintained. When modulating signal voltage is increased, frequency is also increased. And when modulating signal voltage is of low, then frequency is also decreased. So this is your FM signal. Fourth waveform is PM waveform. In PM waveform, if the modulating signal voltage changes its phase from negative to positive, there is an increase in frequency. Similarly, when the modulating signal voltage changes its phase from positive voltage to negative voltage, there is a decrease in frequency. This is called as PM wave.